We could probably talk for a while about the use of like LLMs in like coding agents and things like that, and what their pros and what their cons are. I kind of have a love-hate relationship with them because like they're definitely really helpful in some circumstances, but then there are lots of points where like I'm just like no, you're just gaslighting me, stop it, like just like stop making stuff up here, and of course just telling it like stop making stuff up doesn't really help anything when you understand like all they're doing is like next token prediction really.
Right.
At the same time, like I still find them very useful when I have a very concrete problem to like shortcut the path to like getting a working solution in place. Like, yeah, definitely helpful there. I've also found that you got to know what you're asking for and understand like what it is you need. From an architectural perspective, these things really still struggle.
Welcome back to Leadership Decoded. Today I'm joined by Mason Victors. He's the Chief Platform Officer at Zanskar Geothermal. Mason spent nearly 8 years building Recursion Pharmaceutical as their CTO and CPO. He pioneered AI-driven drug discovery. His philosophy is simple but powerful. I build at all levels, from techniques to teams to people. He's got a master's in math and experience leading cross-functional teams across the intersection of really hardcore science and tech, and really brings a unique insight into AI transformation and deep tech in leadership, which is pretty rare and probably one of the most technical leaders you'll run across. So thanks, Mason, for joining us today.
Thanks, Tyler. Glad to be here.
Yeah. Well, tell us about where you're at now. I know it's a newer gig for you at Zanskar Geothermal, but how did you kind of end up there, and what are you all working on?
Yeah, in terms of how I ended up here, kind of has to start with where I came from. I spent, as you mentioned, about 8 years building Recursion, which was an absolutely phenomenal experience. Just great people, great problems, great technology. But eventually, I discovered that executiving at a 500-person public company just isn't very fun,
Yeah.
and had a growing feeling that it was time to move on and figure out my next thing. Um, and uh, and so I moved on from Recursion about 2 years ago, and I felt two things simultaneously. One, that it was time to move on from Recursion, and two, that if I was going to spend my time for the next several decades in drug discovery, I might as well do it at Recursion, at a place that I'd spent so much time building, which led me to conclude, okay, I need to move on and find a different challenge. And so I spent a couple of years poking and prodding and trying to identify what the next opportunity would be. And I knew I wanted something that was a meaningful problem for the world.
Yeah.
I wanted something that was at the intersection of science and technology. I wanted something local here in Utah, wanted to stay,
Yeah.
and wanted a startup. And that becomes a vanishingly small set of places,
Yeah.
but not completely null. I found Zanskar. It was actually introduced by Chris Gibson, the CEO of Recursion, when
Cool.
he heard of them at an Obvious Ventures event. Obvious backed Zanskar Series B a little over a year ago.
Mm.
And he connected me with the co-founders, started talking with them, realized how fascinating geothermal is,
Mm.
and what an opportunity there is right now at this moment in time. And yeah, ended up getting sold pretty quick and on joining this mission.
Cool. For people that maybe don't know about Zanskar, because I didn't know, and they're local to Utah,
Yeah.
at least have some presence here. What's their mission? What's the problem they're trying to solve?
Ultimately, their mission is to make geothermal the cleanest or the cheapest clean baseload power option here in the US and maybe eventually worldwide. You have to understand that when it comes to energy production, there are a couple of different dimensions that are important to recognize. One is that we're all familiar with is carbon emissions,
Mm.
basically how clean the energy supply is. So if you think fossil fuels, not very carbon neutral
Yeah.
there. But then the other dimension that you need to think about is how on demand or stable the supply is.
Mm.
So when you have things like solar and wind, these are very variable and fluctuating.
Mm.
In some ways predictable, in some ways also not predictable. Predictably, solar, you're not going to be generating any power during the night,
Yeah.
and only during the day. And then unpredictably, you don't know when there's going to be cloud cover, storms, etc. And so those are variable clean energy supplies. But geothermal is a form of baseload power that is also clean. So baseload power means it's always on, steadily operating, at providing some amount of energy in a very reliable, predictable way. And so for that in the clean energy space, you're really talking about like hydroelectric, so dams and water
Yeah.
spinning turbines. Um, uh, I would say like short term, always very reliable. Long term, there's questions. We've seen issues with Lake Mead and Lake Powell and the power productions at those plants due to water levels dropping. But then you have things like nuclear as well that are baseload, carbon neutral, and then you've got geothermal as another option, which basically is always on and very carbon neutral.
Okay, that's awesome. Can consumers get geothermal to their, like, is that an easy thing to do if, say, you were a consumer and wanted to have geothermal energy? Do you have to have something specific piped to your house, or like how do you get it, or is it just that you are working with the electrical plants to kind of use that to generate?
Yeah, it's interesting. So there's residential geothermal, and that's different from commercial geothermal, right?
Yeah.
So residential, some people there aren't that many because it's kind of invasive and quite expensive up front, but
Okay.
people have installed geothermal heat pumps, which is basically a way of tapping into a very stable temperature in
Yeah.
the shallow surface, down, 0 to 60 feet deep, roughly.
Yeah.
Might be deeper. I actually don't have any firsthand experience in residential geothermal. Um,
Yeah.
and that basically relies on the fact that once you get down into the subsurface but stay shallow, it's a very stable temperature year round, pretty much no matter where you are. And it's just
Hmm.
like the heat from the earth emanating out and the heat from the sun, like heating up that soil, and it just keeps it at a nice stable temperature, which is allows you to dump excess heat in the summer to cool your home. So you basically
Yeah.
pump heat out of your home, dump it in the ground, which stores it for later in the winter. Then you can pump that excess heat out of the ground back into your home to
Hmm.
heat your home in the winter. And so you're moving fluid basically
Yeah.
there to heat your home. Or cool it. And so that's direct use, but that's very different from commercial
Okay.
geothermal, which is about generating electricity. And generally speaking, other than like photovoltaics, to generate electricity, you got to spin something. You need a
Hmm.
turbine or something. And so you need to have something that is hot enough, basically, to turn into steam itself, or through a heat exchanger to turn some other fluid into steam in order to spin a turbine to generate electricity. And so that's what commercial
Yeah.
geothermal is. And you have to either find or create hot flowing water. And I'm
Yeah.
talking really hot, well above boiling there, temperatures of water. And so, like, generally speaking, it's something is nowadays considered commercial grade geothermal if you can find water in excess of like 140 degrees centigrade at given
Mhm.
the pressure that it's at deep
Yeah.
in the subsurface that flows enough. So you've got to have enough permeability to like pump that fluid out
Mm.
at a very high flow rate to be able to capture the heat and convert that into electricity.
Okay.
And Zanskar focuses on that. It's not residential. We're focused on making geothermal the cheapest, clean baseload energy supply possible here in the U.S. And we do that by finding hot water deep
Yeah.
underground that we can pump out and flow there, which is different. There are other branches of geothermal that are focused on like enhanced geothermal systems where they basically try to artificially create these reservoirs underground. They'll drill really deep holes. Doesn't matter where, as long as they drill deep enough and then frack it to like create these fractures. So like using oil and gas technologies, but they've got
Yeah.
to like keep those fractures open and have them large enough and connected so they can pump water down one well and then pump it out the other. And basically like they're creating their own conventional geothermal system.
Yeah.
Zanskar is largely focused on finding hidden conventional geothermal systems where that hot water and that permeability network already exists, with the option in the future to step that out and enhance that through these reservoir stimulation EGS techniques in the future.
Yeah.
Basically, like our mission is find that hot flowing water. And that becomes a really hard problem to like
Yeah.
find something like that's buried. We're talking like thousands of meters in the ground, and to be able to say drill right here, and you'll be able to find hot flowing water to produce electricity.
Yeah, I mean that's fascinating and definitely like a not a normal job description. Like, what does your day-to-day look like in your new role? Like, as the chief platform officer over there, how are you helping move this vision forward?
Yeah, so I mean, number one, got to figure out what are the core business objectives at the end. Like, it doesn't matter what your X is in your CXO role. Like, you've got to tie things back to the business and advance the business forward. And right now, being able to identify um, uh, like which of our prospects we have many different sites, we'll call them. We call them prospects here, all over the Western US, land positions where we feel there might be geothermal potential there.
Yeah,
And helping the leadership team decide where do we put our money in terms of drilling deeper holes. Um, uh, the platform's primary purpose is to help people make effective, accurate, timely decisions about how to deploy our capital and our resources. And so
yeah,
that might be a matter of identifying which sites have the largest like megawatt potential of electricity generating potential there.
right.
So like trying to identify excess heat loss in the surface and say, yeah, here's a really big hot area. We should focus here. But then another side of the problem of additional decisions to be made is, okay, we know we want to go here, but this is like, maybe it's a 5 kilometer by 5 kilometer area. We've got a 25 square kilometers. Like, where exactly do we drill
Yeah,
a 24-inch, 24-inch diameter, or smaller, often for the earlier ones, a very small diameter well, uh,
right.
to like try to intersect a fault that has that hot flowing water. And you have to be a lot more precise there. And so we're building a platform to basically help our leadership team and our exploration geologists make those decisions in the most informed and data-driven way possible. And that involves modeling on a lot of different levels,
Yeah,
and identifying where to place our bets, and also figuring out what's the infrastructure that we have to put in place to be able to do this repeatedly and reliably
yeah.
there. And so, what I spent a lot of my time on is trying to figure out, well, which of these problems are the ones that we need to solve right now, and
Mm,
how do I guide the teams to be able to come up with solutions that will both work right now, but also lay a foundation for the years in the future.
right. Yeah, I know when you're at Recursion, one thing you talked about is like the success you all had using cross-functional product-centric teams. And it seems to me that both Recursion and your current position have these kind of like big expensive bets. Like you're ultimately trying to use science to figure out where to go on things that take probably years to come to fruition. Are you still a believer in that type of cross-functional team? Is that kind of what's working for you now, or is that shifted?
I'm definitely a believer in it. I think there's room for improvement here at Zanskar,
Mm,
there in adopting that kind of like product-centric approach. I mean,
yeah,
generally speaking, I deeply believe that one, the hardest problems won't be solved by any one discipline working together. And lobbing things over the fence generally doesn't work. Of like, oh, like I built this thing, now you go productionalize it, or you go like operate this thing. Um, and so you need multiple disciplines working together in some way.
yeah,
And I also, the second key piece here is feel that teams should generally be mission aligned rather than functionally aligned, right?
yeah,
Like they should be focused on like what value are we creating for the company or for the world right now, and be focused on that mission that they have rather than my background experience or my CV or my education or the specific degree I have. Um,
right.
and so teams should be mission aligned, and they generally should be fairly autonomous and independent. So, and that means that you want them to have all the skills they need to operate fairly independently. And so I'm definitely still a believer in like cross-functional, like mission-driven teams, whether you call them product-centric teams or stream-aligned teams or
Yeah,
mission-aligned teams. Basically the same ideas, like they're focused on creating some unit of value, and they have the skills necessary in them in order to succeed without having dependencies on other teams in uh like I would say that like non-service ways, I guess. I don't have you ever read team topologies?
yeah, yeah,
Yeah,
yeah.
yeah,
It's
yeah. So
cool.
like I would say it's on the short list of like technical leadership books that have influenced my thinking a lot
Yeah,
there. And I mean a lot of work slows down and gets bogged down by complexity when you have lots of teams dependent on each other in unclear and ambiguous ways. Those dependencies can be okay if you're very explicit about them.
Right.
In like a platform team is like delivering something as a service to all of the other stream-aligned teams in the company. Like then that's like a healthy approach. But when you have like functional teams,
Yeah.
like function first thinking, then things start to you start to see a lot more friction there because teams can't operate independently.
Yeah, totally. Like in traditional manufacturing, one way I've heard it described is often you have so much time spent in the process and not in actually adding value back to the product, whatever it might be. And if that ratio is really high, often in tech, what I see is it's not very aligned teams. And so they're spending a lot of time talking, going back and forth, not being actually autonomous. And you might only be getting 10% value add from the time and 90% process, which sounds crazy, but when they've done some of these studies, that's not uncommon to see in reality is a lot of process overhead.
Yeah, and I mean, I imagine that there are situations and there are industries where like being very, very process focused is the right thing to do. Um,
Right.
there, but in like hard science meets hard tech, like these are very ambiguous, hard to solve problems that haven't been like distilled down into some kind of industrialized workflow. The
Right.
process of figuring out how to distill it down into an industrialized workflow requires that cross functionality. But I imagine like in manufacturing to figure out your assembly line of how like something is going to be assembled, figuring that out might require that cross-functional thinking. But once you've got it like
Right.
worked out there, then you probably could go into that more like I am just like turning the crank and like pumping out
Right.
this one widget, and then somebody else is doing some other thing because you've created explicit contracts throughout that process.
Yeah.
There and the contracts like are the glue. But when you're operating on something with high ambiguity, you don't have contracts yet. You've got to
Right.
like work in a very agile way to abuse some terminology there, which I think necessitates this kind of like mission-centric team.
Yeah, and I think some of the places you worked more than others has a even more level of diversity. Like Recursion, you're probably working with biologists, technologists, product people. At Zanskar, probably engineers and geothermal experts. Like, how do you get that diverse of a group to work well together? That's not, it sounds all nice when you say it, but in reality, sometimes getting people from very different backgrounds and opinions to kind of move in one direction can be tricky.
Yeah, definitely tricky. There's not like some magic silver bullet there, but one of the things I would say is really critical. I'll say two things here. One is getting really clear on what that mission is, on some
Mm,
like common objective that they can all collectively rally behind and feel responsible for. Um,
yeah,
and that identifying that common objective is probably like the number one most important thing in order to get people playing well together that don't normally play well together. And then
yeah,
the second thing is helping them to see themselves and each other as a first team rather than it being like, oh yeah, we are a task force or a temporary working group here that we're going to have like a meeting every couple of weeks to align. That's not a team
yeah,
because like that doesn't your hat that you're primarily wearing is still like down and in on like my function, like my area of expertise. You've got to like take that hat off and like put on a different hat as no, like I am a leader on this mission. You're like I am on this mission here, and kind of like re I don't know, re-engineer your identity there. So
yeah,
like at Recursion, something that worked really well is helping people show up and shift their mindset to I'm a software engineer and right now I'm working on problem X to like I am somebody who delivers on problem X by using my software engineering tools and
right.
skills. And it's just like a flipping of priority there, but that's an identity shift and that takes time and that's hard to do. I don't want to make it I don't want to make it sound trivial.
Yeah, no, I like that identity shift. It's one thing I've started to believe is like the atomic unit of a company, a lot of people think of as the person, but it's usually more like the team.
100%.
And that's hard because we do like performance reviews at most companies on a personal level. You give feedback on a personal level. And one thing I haven't quite cracked, but I think is something we need to improve on is how do we do more of that at the team level? So like I do a lot more of my meetings than I used to just with the whole team as opposed to one-on-one and have the same conversations. And it might feel a little awkward at first, but you start to build more of like this team mindset as opposed to like I'm an individual that needs to perform and the team is kind of like secondary, which to your point takes time and is hard.
Yeah. I mean, I couldn't agree with you more about like teams being the atomic unit of
Yeah.
value creation at a company. There, you got to celebrate teams, and team wins. I think is key to it. So I had the privilege of being mentored for a while by Kellen Elliott McCree. He was the CTO at Etsy from like beginning through IPO, like brilliant engineering leader. And one of the things that he emphasized was culture is what you celebrate. And the way you celebrate things is through rituals. And so finding like team centric rituals to celebrate the delivery and accomplishments at the team level, I think is really key to like creating that shift to it like a team first mindset and team first culture.
Yeah.
And that's a tool that I found has been very useful there. And then there are some that advocate that generally speaking, like feedback should be given like at a team to individuals even at a team level. Like
Yeah.
because they say it helps with creating, accountability. I haven't really experimented with that deeply. Like generally people say like, yeah, praise in public, like criticize in private. And
Right.
I've generally like followed that, but some of the arguments are pretty compelling to like even constructive feedback being given in a team setting because it
Yeah.
helps everybody know like what feedback is being given and helps everybody like keep each other accountable for improving. So yeah, interesting.
Yeah, I definitely agree with that. And I know NVIDIA's CEO is proponent of these like team style feedback sessions. And I think that I've tried a bit of this, and I think the trick is you have to have a lot of trust in the team already. You can't, if you're a new leader listening to this and you just got a new team, the first thing to do is not that, is like to just
For
go
sure.
straight in and like, okay, guys, we're gonna act like we've built trust. But once you've built trust with a group of people, it can start to feel a little bit natural to just like have these conversations in the open because everyone kind of believes at some point that it's not a personal thing. It's ultimately like, how do we move forward as a team? And they all want the team to win, which is another reason I think long-lived teams are really powerful. And the research shows this. You might take a superstar on a super team and move them to a different team, and they're no longer doing what they were doing.
Oh, for sure.
And we see this outside of companies too, sports and everything. So,
Yeah, yeah, that's something that I felt like we missed. I missed in particular at Recursion, or like didn't understand early on, is how important the durability of a team is and the
yeah,
stability there. I mean, every time you make a change with a team, you restart this forming, storming, norming, performing process, uh,
yeah,
and and you want to keep teams in the performing process as long as possible. And so, like creating stability for teams is huge. Easier said than done in fast-paced evolving startups, but like something that you if you're not thinking about, then you're missing something there. And also then there are also fun examples of individuals that really are like duos that have worked together
Mhm.
like paired at the hip for years and years
Yeah,
and years, and they complement each other so strongly that like their collective value that they create is so much more. It's definitely like a one plus one is way more than two. uh,
yeah.
uh, uh, I'm blanking on the names here. Um, at Google, Jeff Dean and there was another guy that he worked with closely. And I remember reading some article about them. It was like 18 years of them just
Wow.
like they basically like share the same workstation, the same laptop practically. And I don't know how like overblown the article was, but it basically
Yeah,
talked about like these two people, one of whom, is actually both. I think one, kind of hides behind the scenes more than the other one hides behind the scenes more than Jeff does, from what I understand.
right.
Like, one of the like considered greatest software engineers, engineering minds of our time. Like it's really a duo behind that of like two people that know how to work so well together and understand each other, and they've allowed for that stability to exist and like fostered that stability that
Right.
that kind of unlocks a different level of team and a different level
Yeah.
of value creation.
Yeah, it's funny when you find those people that have recognized that with their, duo and they tend to move companies together. You kind of like see them bounce around, which is kind of fun.
Yeah, for sure.
With AI and everything going on right now with AI, I'd be remiss not to ask about it. How are you all thinking about AI in your product and platform, but also in how you develop, like is something I'm really interested in, like in how you work as engineers or whatever your role might be. Like, are you all using much AI in your workflow, in your product? Like, what's kind of your thoughts?
Yeah, so I guess I'll answer that kind of in two different ways. One is that AI in many of its varieties is at the core of what we are building, right? Like ultimately, we are trying to say, hey, go here, in this general area to find a geothermal anomaly. And that requires like taking a bunch of data and figuring out how to make accurate predictions. And so there's flavors of AI like feeding into that. And then beyond that, there are like yet other flavors of AI within that with that second problem of all right, now that we're in this region, we've got some rough estimate of the potential. We've decided like there is enough energy potential here to warrant these more expensive, deeper drilling campaigns to say where exactly do we drill? And this becomes like this really interesting inverse problem
Hmm.
um, where the data you have cannot directly tell you like where you should drill or like tell you what is happening in the subsurface because it's an under constrained problem. Like there are an infinite number of arrangements of the subsurface of the lithologies of like where like rock densities change or where your faults or fractures might be that could explain the same like surface level temperature anomalies or like gravity data or magnetic data or things like that. So you have
Right.
this like really interesting AI inverse problem to figure out, well, how do I estimate like what the most likely distribution of
Right.
subsurface realities might be? And that's a really interesting AI problem. So these AI um, approaches are at the core of what we're building. But then, as you're saying, like how we build, there are opportunities to leverage AI within that. And like we could probably talk for a while about the use of like LLMs in like coding agents and things like that, and what their pros and what their cons are. I kind of have a love-hate relationship with them because like they're definitely really helpful in some circumstances, but then there are lots of points where like I'm just like, no, 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 no. You're just gaslighting me. Stop it. Like just like stop making stuff up here. And of course just telling it like stop making stuff up doesn't really help anything when you understand like all they're doing is like next token prediction, really. Uh
Right.
uh but at the same time, like I still find them very useful when I have a very concrete problem and I if I either want to like shortcut the path to like getting a working solution in place, like yeah, definitely helpful there. Um, uh, but I've also found that you got to know what you're asking for and understand like what it is you need. From an architectural perspective, these things really still struggle.
Right.
And they might be able to create something that kind of works, but is not not ultimately architected for your needs. And so you have to like that human thought I found is still required to basically set up the framing appropriately and create enough clarity of your general design of what you're going for and then have it like do its first pass at fleshing out details. So like I've had some success in like writing full-fledged design docs and then saying all right now like take this design doc where I've been like as detailed as I can over like multiple pages and like now like architect or not architect but turn that into like an MVP solution that we can work with.
Yeah, I've definitely seen similar results for me. In some ways, the more powerful skills are like system level principle type thinking. So you can think through the process. And then you've kind of got like an army of junior engineers who are really enthusiastic that you can help execute on these things, but they're very enthusiastic. So if you kind of set them off on a path that's not well described or something, they might, kind of go wild.
Hmm. Yeah,
And
that's
like
a good
maybe an area
point.
you're uniquely, an expert to talk on is there's some discussion around AI's ability to kind of make new things. Um, and you all are trying to solve problems that aren't solved, obviously. Like these are not solved problems, they're not already figured out. Some places, are just mostly using tech to organize, solve problems in a way that makes people's lives easier, which is great. And AI, I think, is a little bit better at that because it can kind of understand the solutions. Do you think AI will be helpful to you now in the future to maybe solve this really hard technical challenge, or is that beyond the scope of its abilities?
I mean, it mm, in the future, yes, I think there. there will be ways in which it can very directly help us solve some of our problems. Um, I mean, in a way, but I should say that like right now, like when people are thinking of AI as like ChatGPT, LLMs, whatever, like
Yeah.
not so much. Because like you think about what those are doing is it's primarily like token like next token prediction, right? And so like it is basically able to like recapitulate knowledge that it has already learned in many ways, which means
Right.
scientific discovery that's kind of hard because you're trying to probe at things that we don't already know about there. Um, where I think there's some really interesting momentum that I feel like hasn't received as much like public attention as maybe it ought is on the world model side. Are you familiar with like NVIDIA's Cosmos world model engine that they've been developing, which is basically um like a way of creating a digital twin or like an alternate universe that basically like given some state and some like observation or some estimate of some state and some observation and some like action that you can take
Hmm.
identify what the next state is going to be given that construct and if you can create a world model that is accurate and reflects our world then you can run all sorts of experiments in that digital twin world
Right.
without the risks of running or the expenses of running things in the real world. So for example, if you are able to create a real or a world model that captures like the physics of all sorts of moving objects in 3D, then you could simulate self-driving cars or you could simulate car driving with like
Right.
and actually like put agents in that world and without having the risk of them actually causing any real damage to
Right.
anybody. And you can imagine like analogs of that to the geological world here as well. Is like if we can create a digital twin of the subsurface, then we can run experiments on that digital twin um, without having to like actually mobilize a drilling rig and
Right.
like expend or incur a bunch of expenses to actually like drill out a well that goes down thousands and thousands of feet. Um,
Right.
and so in those ways, AI is, I think, enabling different kinds of discovery, potentially scientific discovery there. But I would say, as useful as what most of the world right now is thinking of AI is, it's not poised to like take the scientific world by storm, in my opinion. There's progress being made, but I don't think it's going to come from like increasing your context window of an LLM or anything like that. That's not going to be the thing that like magically enables us to unlock drug discovery or like
Right.
subsurface exploration.
Yeah, I agree. And I think the biggest advancements we've seen over maybe the last 6 months with LLMs has not been the model, in my opinion. It's more the way they've been able to interpret the context for tasks. So like I'm not sure how much better the models have gotten, but we've gotten better at tweaking them to solve problems. Like on engineering, they have the software engineer benchmark. And now more and more models are tweaking to kind of be good at coding, which is some changes to the model, but it's not like they fundamentally rethought the core architecture of how these things work. And for the audience listening, if you're interested in what Mason's kind of talking about, it's generally referred to as reinforcement learning, is the type of machine learning. And one reason it's so good at game playing is you don't need a digital twin because the thing itself is digital. And at least the way my mind thinks about it, is AI is actually pretty unintelligent, but it's really good at learning with a lot of input. Where humans actually with small input can learn pretty well. And there's some things, if you build a really big model, then you can fine tune it. But if you can give it a ton of data, AI is really good. And to your point with self-driving cars, if we could somehow replicate that exactly, we could just drive it around, generate tons and tons and tons of data, train up these agents, and then release them on the wild, which is the same as a simulation. And that's an interesting world. And I think really does tie in with some of these LLMs because one of the things I'm seeing is things that have more programmatic access
Hmm.
are the most susceptible to disruption because the AI can iterate and learn and train. Where, funnily enough, in the coding side, like some of these no-code solutions that were supposed to like help people code better are not that helpful anymore because the AI can't actually directly interact with it. It was meant to interact in like a what you see is what
Yep.
you get. And so it's going to be fascinating how some of these things change in the future, where being very easy to integrate with technology will allow the AI to actually help you more over time and over learning. And if that connection's hard, and that's where like physical labor, robotics gets a lot harder because the connection's not as strong. It's much, much harder for AI to help right now.
Yeah, yeah. I think a key part of that also is where data and acting is cheap is where there's going to be like easier breakthroughs to happen, right?
Right.
Um, and so you're talking about reinforcement learning of being able to like act in your environment. If you can act in an environment where those actions are cheap to do, then you can act a lot.
Yeah.
And you can learn a lot from those actions and the outcomes of those actions. And so, like, this is, if you recall back to like AlphaGo Zero and how
Mm,
impressive that was of just like self gameplay. That's because like you have a very defined state space that you can act in, and there's no ambiguity about like how the state changes with
right.
the actions that you take, and that allows like infinite self play at only the cost of the electricity and the hardware, to like actually like run those training regimes.
Right.
But if you're talking about like other very expensive actions, and that's the only way to really learn. Say you're talking about like clinical trials and drug
Right.
discovery. When you're like finally going to put a drug in a human being, like that's expensive, that's scary. You can't really self gameplay that, right? You
Right.
can't collect that data cheaply. When you're talking about like punching a hole in the ground that goes down 1,000 meters, like that's expensive.
Right.
And so I think a key component that is critical now for kind of the next wave is figuring out, well, how do we take these traditionally very expensive areas of action and turn them into like trivially inexpensive simulated action that are highly accurate in those simulations. So then we can learn how to act in that environment in a safe, low cost way where we can like do an insane amount of iteration and experimentation and thus self-learning there.
Yeah, I think it's going to be fascinating. I mean, and I don't know much about what recursion was doing or is doing, but what I understand is one of the core beliefs is like we can build up a big data set bigger than other people, which we can learn from. But then, like, I think about the next level where we talk about this digital twin. Even if we can't perfectly replicate, let's say, the human body and how it will interact to everything, if a company could build a digital body that even improved the rate of success with a new drug by 5%, that's probably game changing for the entire industry. Like on these huge, huge bets that some of these industries have to make, if you can move that distribution that you're trying to figure out a little bit closer to reality, it's enormous amounts of value created.
Yeah, absolutely. One of the hard things there is that the realization of that value is so far in the future often that uh, there's a question of like, will you survive long enough to be able to see that? Like that, I think, is the biggest question when it comes to things like AI driven drug discovery or like what we're building here at Zanskar is, will we be able to uh, take enough shots on goal to
Yeah,
be able to see that shift, and there, and will we have a long enough time when you have things that take years before they can mature to fruition, right? So like a full set of clinical trials takes 5+ years to run, right? So
right.
like you have a very long delay before you know if what you built actually, creates any value. And when it comes to like setting up a new geothermal plant, just the permitting process alone of getting the approvals from like the governing bodies, like creates such a time lag. So I think one of the real questions that we've got to face is, okay, yeah, maybe you can improve at 5%, and that enough that is sufficient to be really game changing. Are you going to be able to demonstrate that 5% improvement before you run out of funds
Yeah.
and run out of shots on goal? So it's
Yes.
these hard like science tech problems. They're different from like your typical SaaS company or whatever, where you're like your iteration is as cheap as your ability to like pump out some new product and get it in the hands of users. Um, yeah, different constraints.
Yeah, and that begs kind of this interesting question for you, like coming back to the leadership side. How do you make decisions as a leader in such a long cycle? You know, having spent your time in industries that have these super long cycles to see if you even made a goal or if you were way off goal or whatever. And where SaaS typically has these really short cycles that you can learn on and iterate, A/B test, all this other stuff, how do you get signal out of those noisy 5-year bets and figure out, are we on the right track? Do I need to move my team somewhere else or make adjustments?
That is a great question, one I'm still seeking answers for, right? You know,
I
like,
was hoping you had them.
yeah, yeah, yeah. I mean, part of me is still looking back at my time at Recursion and wondering, like, all right, did it work? Did anything work? You know, like fingers crossed. I don't know for sure. Like I won't know until we see that we actually have a 5% or hopefully more improvement
Right.
on like clinical trial success rates due to the process that we use to develop, discover and develop our drugs. So like the jury's still out there, I think.
Yeah.
That is like very anxiety inducing, I'll say,
Yeah.
for sure. Um, and yeah, like how do you score yourself or measure yourself along the way? Um, I mean, you can definitely it's interesting. This is a fundamental problem, not just true to these like long bet companies, but also like research itself is inherently that way. Like you don't know what's going to work. You don't know how many things that you try are going to fail before you like hit something that's meaningful, which which is interesting because then you have like other problems that and I don't want to underplay these at all because uncertainty and difficulty are two very different things that are both like really important to pay attention to. But like
Yeah.
there are engineering problems where you have very low uncertainty. It might be difficult to implement, but you know it's entirely possible to do. And
Yeah.
those problems, sometimes I find myself gravitating towards those because I'm like, I know I can do this and I know I can know that I did it. Whereas like the research problems, like, these are really important, really high uncertainty. Like, I think I can do them, but I'm not even sure if I know how to grade ourselves on whether or not we did them. But
Right.
those also are like inherently more fascinating problems to me. Um, like I remember thinking this when I went first went to Recursion that at the time I remember being surrounded by people that were I would say they were alpha chasers. You know, it's like they've got some like very well defined task, machine learning task, and they're just trying to like reduce the loss a little bit more, like increase the accuracy or whatever, like a couple of metrics that they have.
Yeah.
And they're just like hyperparameter tuning, and this is like pre like hyperparameter optimization
Yeah.
frameworks and things like that. They're like trying to tweak all these things and like feature engineer or whatever to chase it. And I'm like, yeah, like that's kind of interesting, but I think it's more interesting to try to figure out what good even is. Like, how do you even like define success in some of these problems? And that's like part aggravating and part fascinating to me.
Yeah. Yeah, yeah, it's super fascinating. And I asked the question because for me, one of the biggest transitions mentally when I went from being a hands-on keyboard engineer, data scientist, whatever, to like leadership is you get this dopamine hit when you're an engineer of like, okay, there's a problem and I solved it, and I know I solved it like almost in the same day a lot of times because the bug's gone or you ship something or the code is running when it wasn't before. And so you kind of like get this dopamine, and when you go to leadership, that dopamine kind of starts going away because it's like you're making all these bets, but you don't know maybe over years what's going to happen or if you did the right thing. And you kind of, I get why some people are like, oh man, I missed the days on keyboard. At least in one respect for me, is like you miss that reinforcement learning loop coming back to you much faster, which I always like is like having a growth mindset. It's like, okay, I did this and I did that and I got these outputs. And now I'm like, there's things I did years ago that I'm still not sure if they were right.
Yeah. I mean, and there are things that you can look as a leader and be like, okay, the team was able to deliver this. Maybe I didn't do it myself, but I was able to help
Yeah.
guide them to deliver something that is, you know, if not correct, it's at least defensible,
Right.
and like, yeah, this is like clearly well thought through and like a reasonable approach to take here. Um, and so I think you do have to step back and look at a longer time frame and your impact from a distance there. Um, and then the other thing as a leader that I think keeps me sane is when I am able to get feedback from individuals of the impact I have on them as
Right.
individuals. Um, I mean, so I'm a guy that struggles with imposter syndrome galore. Like it's it's been an issue for me for 20 some years, ever since like, high school and college, like that's fine, but once I like was focused on real world problems, yeah, like a lot of self-doubt creeps in and uh and I found one of the things that keeps me sane is actually like the set of notes that people have written me
Yeah,
of like the positive impact I've had on their lives. Like I have some in my car, like the center console, that I'll like pull out and read when I'm like struggling with questions of am I doing anything of value here? And I
right.
have to look at those and realize like, hey, at least I helped this person grow in this way. And I think so. I think being able to take a step back and look at like the value that the teams that you ultimately guide are able to create, but also like the impact that you have on individual people and helping them grow, not just as data scientists, ML researchers, or engineers, but as human beings, like
Yeah.
that that has value. That has incredible value.
Yeah, I love that. I think that's super grounding and hopefully something people take note of. Because it is hard. Like one of the things I kind of start to believe in recently is as leaders and really as anyone in a company, the truth is you're being judged on outcomes most of the time. But often you cannot control the outcomes completely. Maybe you have a large degree of ability to change them, especially as you go up like a leader. Maybe you're responsible for the top line revenue of a company as a CEO. And sure, you have a lot of ability to impact that number, but you ultimately can't change the macroeconomic environment, policy, all sorts of things are outside your control. And so at some point you start to realize, at least from what I think I realize, is the journey is maybe as cheesy as it sounds the thing to optimize for, which is what you're saying is like, did you make decisions that you feel like are defensible? Did you, do the things that felt right for you and your team? Did you make a difference in people's lives? And ultimately, I do believe those things are probably going to maximize your chance of getting an outcome. But for a lot of leaders, it's hard to start separating yourself from that because often you're, driven to perform. You performed in school, you got good grades. You might be in a situation where you're doing all the right things and you don't actually get like the straight A where your company takes off and is doing all these things. And that's a different mindset, I think.
Yeah, it's an uncomfortable one, right? I mean, it's
Yeah,
one that leads me regularly to question, why did you sign up to be a CPO again? Like, like you should have just stuck with individual contribution, you know?
right.
But it's one where like you make a trade-off. Like your impact has a higher probability of much greater breadth,
Yeah,
but far less precision on any individual outcome. Right? Does that kinda make sense? And that's true, like, the more you shift into, like, broader leadership or management, you have potential for massive high breadth impact, but, like, low precision ability to, like, be able to impact any one granular thing.
yeah,
And you have to be okay making that trade-off.
yeah, totally agree. Well, I know we're kind of coming up on time, but I do want to kind of do some quick fire questions just for fun. No need to overthink them. Um, but I'll just kick it off. What's the best programming language in your opinion?
Uh, yeah. Uh, I mean, the Python ecosystem is just so huge that I couldn't choose anything other than that, I think, in terms of its versatility, especially when it comes to, like, bridging hardcore scientific computing with, like, robust engineering systems to be able to make that industrial scale and sustainable. Yeah, I think Python's hard to beat.
Yeah, agreed. What's the biggest leadership myth, like thing you hear people say all the time that you just don't buy?
Mm. I don't know if I would say I hear it all the time, but definitely experience this myself and seen others experience it, thinking like Fang is always best. You know,
Mm,
like you want to hire from the big tech companies, those are the right people to hire. It depends on your context. If you're like a small startup, oftentimes those can be some of the worst hires to make because they're so used to like operating in an ecosystem where like everybody else is already handling like bits and pieces, and they're like so narrowed in their focus of what they do that
right.
that they can actually be ineffective. But then at a later stage, like they're exactly who you want to have there to like operate within that framework. So there's, I guess really the myth is that there is like a one size fits all ideal engineer, or
Yeah.
data scientist or ML researcher.
I like that. One book every leader should read.
Yeah, I already mentioned it. I feel like in technology, if you are a leader in managing people, team topologies is key. Like understanding Conway's law and how the choices you make organizationally can impact the architectures that you end up with, key.
Yeah, great one. It's also not too hard of a read, honestly. What's the hardest part about being a C-level leader?
For me, the weight, I would
Mhm.
say, like I feel it all. And this was this is part of what made executiving at a 500-person public company at Recursion like stop being fun is this feeling of like, oh yeah, we actually have something to lose now, you know?
Yeah.
And like if it fails, like I'm gonna feel like it's all on me. Like if it fails right now, it's going to be past Mason's fault, and if it fails in the future, it's going to be current Mason's fault. Either way, I'm gonna feel it. Now I know
Right.
like that. That's I guess like my mindset of like take the blame, like shift the credit of like my mindset naturally doesn't like look at the upside as much.
Yeah.
But that weight is heavy, and I think that's the hardest thing for me as a C-level exec.
Yeah. Yeah, totally. What's one skill you wish you'd learned earlier?
Hmm. I wish I had learned the art of tech leadership, and I mean like technical project planning and management earlier on. I feel like it's often and tech leading is often an underemphasized skill in early startups. And that's where I spent most of my time. And so I never really focused on it or thought about it until I realized it was a gap that we had and that I needed to figure out how to teach it. And so that
Right.
was part of like, all right, I got to figure out how to teach this skill when I'd never like consciously practiced it myself. It became really fun when I stepped away and went back to like an IC role for a while to then be like, all right, now I can like practice this thing that I had like spent time trying to teach, but it was something I wish I'd learned earlier on, and something I
Yeah.
think like early stage companies could do a better job of emphasizing is like tech leadership, tech leading as a discipline. And I'm not talking about people management. I'm talking about leading a
Right.
technical project.
Yeah, I think even more valuable with AI, because in some ways AI gives you these little people to help you, and if you're good at managing tech projects, you can leverage them.
Yeah, absolutely.
Um, One prediction for the next 5 years.
Yeah, we already kind of touched on this a bit also, but I think 5 years from now, people will realize how limited LLMs really are.
Hmm.
And there will be a realization that they were a stepping stone to something better. And then I think we'll probably repeat that cycle, every 5+ years. Um, I mean, it's kind of funny to like look back at like 2015. That's for me like when I started actually like shifting over into more like the deep learning world and
Yeah.
understanding the research going on there. And man, you look back at that and like the things that we felt were so cutting edge then, and realizing like how all of that has been, was supplanted 5 years later, with that. And I mean, granted, like, okay, attention mechanisms started coming out like shortly around that time, but then
Yep.
like transformer networks and everything. So like seeds were planted, but then like coming to fruition. And like, I would have never thought like, oh yeah, you're going to find something like way better than convolutions, when you're dealing with like image, computer vision work and then just like seeing that totally upended. Um, but then like, yeah, it's probably going to be upended again, like, and I think oftentimes we feel like, we've arrived or we're almost there. I don't think we have any idea where the horizon is. And
Yeah, I
hopefully we'll realize that soon that we don't know where the horizon is.
yeah, that's my belief too. I gave a talk once on the history of AI, so I did a little bit of
Mhm.
research into like it's very similar cycles, and that's just how humans are. There's the hype and then things come down, but still
But I
really
think the
cool.
fascinating thing is I feel like we haven't really had like another trough of disillusionment yet.
Yeah, it's been a
Like
while.
in like this new like era and wave of AI and machine learning, like it's just continued to go. And I don't know that we're going to have like a true trough of disillusionment or like dark times
Yeah.
again, like there were. I mean,
Yeah,
like yeah,
winter.
like the history of neural networks is really funny to see, like from
Right.
the first multi-layer perceptron, and this like, oh, this is like a general problem solver, and then realizing like, no, can't work because of compute, whatever,
Right.
research, and then like another resurgence and then like falls back, and now there's this resurgence. Like we'll probably have minor trot like dips of disillusionment, but I have a hard time seeing it go into like the level of disillusionment that has happened in the past.
Yeah, I think that's true. It's enough proven value that I think it's here to stay.
Yeah.
Well, I know we've got to run, but any last words, contact information? I think you all might be hiring still, so any types of people that should reach out?
Yeah, definitely reach out to me, Mason at Zanskar.us. If you want to chat, if you want to learn more about what we're doing or talk about tech in Utah, or tech meets science, totally happy to jam. Right now, we actually closed our last open technical role
Oh,
that we had until our next funding
congrats.
round. Um, But I expect sometime in the next 6 months we're going to have another big hiring spree. So if you come with really solid engineering experience or computational geoscience or geophysics, we should definitely chat.
Cool. Well, thanks again, Mason. Really appreciate you taking the time. I'm sure it's crazy busy what you all are doing, but super fascinating and best of luck.
Okay, thanks, Tyler. Take care.
You too. See ya.